Have you ever wondered what makes up everything around us? The trees, the stars, even you and me? The answer, my friends, lies in the fascinating world of atoms. Our journey begins in ancient Greece with philosophers like Democritus. He imagined tiny, indivisible particles that make up all matter. He called them atomos, meaning uncuttable. Democritus's ideas were revolutionary. He believed that atoms were constantly in motion, colliding and combining to form everything we see. This was a radical departure from the prevailing belief that matter was continuous and could be divided infinitely. While Democritus's ideas were insightful, they lacked experimental evidence. Without a way to test his theories, the atom remained a philosophical concept for centuries. Fast forward to the 19th century, where an English chemist named John Dalton brought atoms back into the scientific spotlight. Dalton was a meticulous experimenter. He studied how elements combine in fixed ratios to form compounds. This led him to propose his own atomic theory. Dalton's theory had several key points. First, he stated that all matter is made up of atoms. Second, he said that atoms of a given element are identical in mass and properties. Third, he proposed that atoms of different elements have different masses and properties. Finally, he stated that atoms combine in simple, whole number ratios to form compounds. Dalton's atomic theory was a major breakthrough. It provided a solid foundation for understanding the nature of matter. And it paved the way for future discoveries that would delve even deeper into the atom's secrets. At the end of the 19th century, a physicist named J.J. Thomson made an astonishing discovery. He was studying cathode rays, which are streams of electrons emitted from a cathode in a vacuum tube. Through his experiments, Thomson determined that cathode rays were actually tiny, negatively charged particles. He called them corpuscles. We now know them as electrons. Thomson's discovery was groundbreaking. It showed that atoms were not indivisible after all. They contained even smaller particles. Thomson proposed a new model of the atom, often called the plum pudding model. He envisioned the atom as a positively charged sphere with negatively charged electrons embedded in it, like plums in a pudding. Early in the 20th century, a physicist named Ernest Rutherford conducted an experiment that would revolutionize our understanding of the atom. He fired alpha particles, which are positively charged particles, at a thin gold foil. To his astonishment, most of the alpha particles passed straight through the foil. Only a few were deflected at large angles. This unexpected result led Rutherford to propose a new model of the atom. He suggested that the atom is mostly empty space, with a tiny, dense, positively charged nucleus at its center. The electrons, he proposed, orbit the nucleus like planets around the sun. Rutherford's model was a major departure from Thomson's plum pudding model. It showed that the atom is not a solid sphere, but rather a vast empty space with a tiny nucleus at its core.